Hi everyone. Just wanted to take a minute to talk a little bit about the laws of sine or the law of sine and the law of cosines. So these are kind of two ways that you can use some trig properties to be able to solve um, for different side lengths of not necessarily right triangles. There are some specific rules to follow, but overall it is really kind of just plugging into a certain kind of given formula. So it shouldn't be anything too crazy. So in terms of what we're doing, we're going to be solving for missing sides and angles of not necessarily right triangles. I'm using the law of sines and cosines. You could use the law of sines or cosines for right triangles, but in general, you usually just use the regular trig properties for that, so you usually don't bother. But there's nothing saying you can't. All right, so what is the law of sines? So the law of sines essentially is it's a ratio. So the sine of the angle A over the side length A. By the way, if here's A, the angle opposite is going to be the smaller case version of that, is equal to the sine of angle B over B, which is equal to the sine of angle C over C. And essentially what you can kind of do to show where this comes from is if you kind of make this into a right triangle, you could use some trig and get the h's, right, if you call that the h. You can use trig and get some h's to kind of cancel everything out and eventually solve for this. But ultimately, this is just kind of a nice property that you can use to be able to solve some problems. Now, it does require you to know either two angles or to, in general, you know two angles and a side. On occasion, you will be tasked with the situation of two sides and an angle, but in general, you usually will use two angles and a side. All right, so let's solve this particular problem. So here's what we're given. We have to solve for E. We're solving for this, and we have all three angles. By the way, if you have two angles, you have all three, so it really doesn't matter. But we can use the law of sines to solve for this side. Normally, you wouldn't be able to. You could kind of give a rough estimate, right? Like if 7 is the smallest, you know it's going to be bigger than 7 by the triangle inequalities. But you don't necessarily know what it is. So now we can actually find out what it is. So I know that sine of 67 degrees over E has to be equal to, again, you pick any angle on its opposite side. So in this case, we could use the 59, but we don't know this side, so that won't help us. But we can use the 54 over 7. All right, so now you have to solve for E, and this is just a ratio, so all you're going to do is cross multiply. So you know E times sine of 54 is equal to 7 times sine of 67. I'm going to divide both sides by sine of 54, so I get 7 sine of 67 degrees over sine of 54 degrees. And now from here, what you're going to do is you're just going to plug this into a calculator. So you can go to your calculator. Let's clear everything. Remember, be in degree mode, please. Don't forget to be in degree mode. I already forgot the numbers. 7 sine of 67 and sine of 54. 7 sine of 67. I'm going to put the divided by sine of 54. All right, and your answer ends up being 7.96 and 965. It doesn't give you a rounding. Usually if you're not given something to round to, usually you would round to 3 decimal places. I already forgot, 965? Yeah, 965. So if you're not given 3 decimal places, if you're not given a number of decimal places, usually you kind of do about 3, as long as you're consistent. Stick with something. So as you can see here, we knew it would be bigger than 7. We knew it wouldn't be that much bigger, right? The biggest is only 67. So you knew it wouldn't be that much bigger. So it makes sense that this number makes sense as an answer, right? All right, let's do another one. So again, with law of sines, you're largely going to be kind of going through this process. So we here have sine 29, right? because you have the opposite and an angle and an opposite over 11 is equal to sine of b over 20. So I have to solve for b eventually, right? So I know that sine of 11 times sine of b is equal to 20 times sine of 29. I'm going to divide by 11. So now I have to deal with the sine of b. So you're going to do the inverse trig. Now you do have to be careful with this. Right? Don't forget about the inverse. So let's plug this in. I have inverse sine of 20 sine of 29 over 11. Okay? So inverse sine of 20 sine of, I already forgot the number, 29 divided by 11. All right? So you do get as an answer here 61.8. Now, in the future, when you're dealing with not necessarily triangles, it is possible for you to kind of have two answers for this problem. It's something called the ambiguous case of law of sines. Given that we are dealing with triangles, you know your number has to be between 0 and 90. So we're really not going to encounter that issue for us. But just be careful if you do see somewhere that it says like this is the ambiguous case. Just make sure you're all set with that. All right, so our answer is going to be that this is, I just forgot the number, 61.8 degrees, 830, or 820, I should say. So we would know that B is equal to 61.820 degrees, which makes sense, right? If this is 29, you know it clearly has to be bigger. So that makes roughly sense. All right. So that is one of the processes we are going to go through. So the next case that we can deal with, oh no, one more. Let's make sure we know what we're doing with words. So when you're dealing with the law of sines here, you do have to be careful. Make sure you set it up correctly. My recommendation, draw a triangle. F, G, H. So remember, the side opposite's the lowercase. So this is 37. This is 28. This is 124. And so down here, you're going to have the other ones. Oh, you need G. Okay. So we have sine of 124 over G is equal to sine of 28 over 37. So let's cross multiply. I'll get 37 times sine of 124 equals G times sine of 28. All right. I'm going to divide, so I get G 37 sine 124 over sine of 28. All right, so 37 sine of 124 divided by sine of 28. You get the answer of 65.338. And I forget what it tells you to round to. So 65.3, right? 65.3, yes. All right, so your length here is going to be 65.3. All right, and there you have it. So that is ultimately going to be how you're going to deal with law of sines. It should be relatively straightforward. You're pretty much just setting up the ratio every single time. I find it tend to be a little bit easier to work with than the next one we're going to look at. So this is the law of sines. Just make sure you set it up correctly and you know which one is opposite, and we shouldn't have a problem. When you deal with this again in the world of high-level math, you'll kind of be dealing with like less shape-related pieces of information, if you will. So I shouldn't say that. It just makes life a little bit harder when you're kind of looking at all potential quadrants and things like that. So now we're going to move on to the law of cosines. And again, as you can kind of tell, this just looks like it's a derivation of like essentially the Pythagorean theorem. And it is kind of similar to that. It really does kind of come down to manipulating everything with making this a right triangle. So there are three different versions of the law of cosines. So you have a squared is equal to b squared plus c squared minus 2bc times cosine of a. You're just gonna have to write these down or somewhere and reference them. It's kind of nobody necessarily remembers them off the top of their head. I personally don't. The law of sines you can probably remember a little bit better. Maybe not this one as much. But anyway, so essentially what you're going to do is, depending on what information you are looking for, you're going to set this up. It also kind of depends on what you have. It does really require you to have at least two sides for you to do this and an angle. All right, so it's really kind of dependent on which angle you have and how you set this up. And I'll show you what I mean by that. So see here, we have A, and then we're looking for little a. But you can kind of see here, we don't have another angle, so we're not going to use really the law of sines, and we're not solving for a side. So again, we can't really use the law of sines. So we need the one essentially where we have a, big A, and we're solving for little a. So little a squared is equal to b squared plus c squared minus 2bc cosine a. All right, so a squared is equal to b squared plus c squared minus, take a look back, have it somewhere, 2bc cosine of a. All right, so now we have to just plug it all in, is really all it comes down to. So we have a squared is equal to, what is b squared? B squared, remember, that's the little b. 21 squared plus 32 squared minus 2 times 32 times 21. I think I just flipped those, but that doesn't matter. You're multiplying anyway. Cosine of 40. And now, really, you just kind of have to put this into a calculator. Okay, and you know what? Let's take the square root of that. Let's just take the square root of all of this. So 21 squared plus 32 squared minus 2 times 32 times 21 times cosine of 40. Now, if any of these were particularly easy and you knew how to simplify them off the top of your head, just do that. So A is going to be, by the way, I didn't do plus minus because it doesn't make sense for me to have a negative side length. So let's plug this in. The square root of 21 squared plus 32 squared minus 2 times 32 times 21 times cosine of 40. And you should get that your side length is going to be 20.867. Which, I mean, that looks like it's going to roughly make sense, right? If this is, these two would probably be about the same. Sorry, these two angles look to be about the same. Maybe a little off, but that's okay. As long as they're close enough, it's fine. So this kind of does make sense as a number. And yeah, so it's really just a matter of plugging it in and simplifying. It's not necessarily hard. It's just working with the numbers and making sure you don't forget. All right, let's do another one. So we have all three sides, and now we need A. So again, if I'm looking for big A, I need the one with angle A. All right, so you need the one set up here. So it's really the big difference is whatever angle you have, the small letter version of that is going to be on the left-hand side. So we're essentially going to do the same thing, but now we have to solve for A. Okay, b squared minus 2, oops, that's a horrible 2, 2bc cosine A. Okay, so what do we have? A squared is 12 squared. Now this is one that you do want to simplify as much as possible. B squared is 13 squared. C squared is 5 squared minus 2 times 13 times 5 cosine A. Okay, so this is 144. That would be 169 plus 25 is 194 minus 13 times 5 is 65 times 2, 130 cosine of A. I'm going to subtract that. Negative 50. And again, you might be kind of spooked out as to why we're having a negative here, but it's okay because that part's negative. Negative 130 cosine A. Divide by the negative 130, I get 50 over 130 is equal to cosine A. So that would make A be equal to cosine inverse of 50 over 130. All right, so we have cosine inverse or arc cosine inverse arc cosine of 50 divided by 130. All right, and there you get it, 67.380. .380, and we're looking for degrees. And there you have it. So it's nothing crazy. It's just really a matter of making sure you plug in correctly. All right. Let's do one more for good measure. This one is a word-based one. All right. Again, when in doubt, when you have words, draw a picture. K, L, M. This is 78. L is 460. K is 700. And I need M. All right, so I want, again, whichever one is the big one squared, whatever letter you're squaring, that's the angle that's going to be in there. 700 squared plus 460 squared minus 2, 700 times 460 times cosine of 78. Again, I'm going to end up doing the square root of that. And let me just plug that into a calculator. So I want this, that's of 78, 460, 700, 460, 700. Plug that in. You should get, when you take the square root, about 753.462. And there you have it. So that is how you do all of those problems. Just as a heads up, essentially what you're going to be doing when you're dealing with these problems is the rule is going to be if you have two angles on a side, AAS or ASA, law of sines. When it is side angle side, 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 law of sines. And then side angle, you are going to use law of sines. But again, that is the situation with the ambiguous case, as I was talking about earlier. But for our purposes, we're really just going to be using law of sines. All right, so let me know if you have any questions, and have a great day.